Okay, Assalamualaikum. Okay, today we move to the new chapter, which is some discrete probability distribution. Okay, this is the special probability distribution, which is some of the discrete and some of the continuous probability distribution will have the specific name for it. Okay, ianya discrete PDF, tapi we have the special name for that function ataupun for that distribution. Okay, so kalau kita baca kat sini dia katakan no matter whether a discrete probability distribution is represented graphically by histogram, in tabular form, or means of a formula, the behavior of a random variable is described. Often, the observations generated by different statistical experiments have the same general type of behavior. Okay, ada beberapa situasi yang we have the general type of behavior. So consequently, this discrete random variable associated with these experiments can be described by essentially the same probability distribution and therefore can be represented by a single formula. So from that, we create the formula dan namakan that formula sebagai Bernoulli, binomial. We will have geometric, hypergeometric, Poisson. Okay, so in this chapter, you will see macam mana, okay, how the situation for each special distribution tersebut, and then how we deal with that. Okay, so daripada situ juga you kena tahu dia punya mean, variance dan juga actually the MGF also. Okay, I go one by one. Okay, untuk binomial, okay, our syllabus akan cover binomial distribution dan juga Bernoulli distribution. Okay, an experiment often consists of repeated trials, each with two possible outcomes that may be labeled as success or failure. So, kita punya outcome ada dua sahaja. Success or failure, 0 and 1. So, the most obvious application deal with the testing of item as they come off an assembly line where each trial may indicate a defective or non-defective item. Ada dua sahaja. Failure or success, defective or non-defective, die or live. Kan ada dua benda yang ada dua. Ini dipanggil Bernoulli Process. Okay, the process is referred to as the Bernoulli process. Each trial is called the Bernoulli trial. Okay, if you look at here, strictly speaking, the Bernoulli process must possess the following properties. The experiment consists of repeated trials. Akan buat beberapa kali. Each trial result in an outcome that may be classified as success or failure. Ada dua sahaja. Success or failure, ada 0 and 1, so defective or non-defective ataupun like I said tadi, die or live. Okay, ada dua trial sahaja. Itu adalah dipanggil Bernoulli process. And then the probability of success denoted by P remain the constant trial from trial to trial. Okay, so untuk Bernoulli dan binomial, actually, dia punya, kita punya parameter untuk Bernoulli distribution dan binomial distribution adalah P, which is the probability of success. So tadi Bernoulli process ni ada dua, sama ada success or failure. So P di sini adalah probability of success. So P ni adalah parameter untuk Bernoulli dan juga binomial. So you kena tahu what is the P di sini. P adalah probability of success, so you kena kira the probability of success. Okay, kena kira probability of success. You know how to find the probability. It depends pada, ini untuk discrete it depends pada you punya variable nanti. The repeated trials are independent, should be independent. Okay, maksudnya macam let's say kita toss 2 coin. Kan? Dia punya trials kan independent. Toss yang pertama, probability untuk dapat head 0.5. Probability untuk dapat tail 0.5. Untuk yang kedua pun, the second toss pun benda yang sama. So, it is independent. Okay. Okay, contoh dekat sini, consider the set of Bernoulli trials. Set of Bernoulli trials. Bernoulli ni, satu trial sahaja. Satu trial tu adalah Bernoulli. Kalau set of trials, ianya adalah binomial actually. So, kat sini dia kata, set of Bernoulli trials where 3 items are selected at random. So, maksudnya dia buat 3 kali lah sebab dia nak select 3 items. And classified as defective or non-defective. Okay, ini adalah Bernoulli process. Sebab kita ada 2 sahaja trials, defective or non-defective. So, actually, function untuk Bernoulli adalah probability. Ini adalah probability of success. Kita tahulah kita punya success tu apa. Okay. Biasanya, success adalah the variable tu adalah the number of success. P power of X 1 minus P ataupun kadang-kadang some of textbook dia buat Q. Q tu adalah failure. P adalah success. So 1 minus P ataupun Q adalah failure. 1 minus X. So dia punya possible value untuk X hanyalah 0 or 1. Sebab ada satu trial saja. Untuk Bernoulli, satu trial saja. Setiap kali trial tu dipanggil Bernoulli process. Okay. Bernoulli process, ini dia punya function. Tapi kalau kita buat beberapa trials, contohnya kat sini kita nak pilih 3 items, so akan buat 3 trials lah. So, proses ni nanti dipanggil binomial. Okay. The process you nak select the item which have only 2 outcome, ianya adalah Bernoulli process. Okay, but if you have several trials of Bernoulli, ianya adalah binomial. Okay. Okay, saya pergi dulu kepada binomial. Okay. Kata the number of X of the success in n Bernoulli trials is called the binomial random variable. Okay, beberapa Bernoulli trials akan jadi binomial random variable. The probability distribution of this discrete variable is called the binomial distribution, and its values will be denoted as B, X and P. Ataupun kadang-kadang X ni refer pada kita punya variable. What is the variable kat sini? Okay, dia kata depends on the number of trials and the probability of success on a given trial. So, kena tahu how many trials N dan juga P. Okay, so binomial. Kalau binomial, kita punya parameternya adalah P sama macam tadi, Bernoulli. Dan juga N, number of trials. So, kadang-kadang kita akan tulis macam ni. X having the binomial distribution with parameter N dan P. P adalah number of success, probability of success. So, kena kira lah probability of success. N adalah number of trials. Kalau contohnya dekat sini, di sini, maksudnya X adalah binomial. X-nya 2. Nak cari 2. X kat sini adalah number of defective. X adalah 2. N adalah 3. P adalah 1/4. Contoh. Okay, saya pergi dulu kepada ni. Pergi dulu kepada formula nak dapatkan binomial distribution. Tadi Bernoulli, kalau kita tengok seakan-akan sama. Kan Bernoulli tadi, Px 1 minus P power of 1 minus X. Untuk binomial, okay, di sini sama. Px, Q ni adalah 1 minus P. Q adalah 1 minus P. P adalah probability of success. Q adalah probability of failure. Okay. N minus X. Sebelum ni 1 tolak X sebab kalau Bernoulli kita hanya ada satu try saja, 0 and 1 saja. But untuk binomial, dia punya possible of outcome sehinggalah N trials. 0 until N trials. So dekat sini, NX kat sini means that NCX. NCX, N combination X. This is a formula untuk binomial. If we have several Bernoulli process, several trials of Bernoulli process, so that distribution dipanggil binomial distribution. Okay, kita tengok contoh yang tadi. Okay, this contoh tadi. So, dikatakan 3 items are selected. Okay, dia punya ni outcome sama ada defective or non-defective. A defective item is designed as a success. Okay, defective as a success maksudnya X kita adalah number of defective item. Okay, X adalah, defective item as a success. So, maksudnya X adalah number of defective items. Okay, so possible value untuk X, possible value untuk number of defective item will be maybe 0 defective item yang you akan select daripada 3 tadi, maybe 1 defective item, maybe 2 defective item, maybe 3 defective item. So the 8 possible outcome will be like this. Kalau you buat 3 kali, non-defective, defective. 3 kali kan, non-defective, defective. Okay, 3 kali. Sama di sini. So, last kali, you akan dapat 8. This 8 combination of. So, kat sini NN, di sini D, NNN, D. Okay, will be here. So, X kat sini adalah number of defective item. Possible value of number of defective item sebab success kat sini adalah defective item. So, kita punya variable adalah number of defective item. So, kalau kita buat manually, akan jadi macam ni lah. Okay, tapi kalau daripada kita punya situation ni, kita boleh katakan this situation ni adalah we can create the binomial distribution. So, you punya function, kita punya function of X, which is number of defective item, ini will be NCX tadi. So, 3CX. Okay, P, probability of success. Kena tahu probability of success. Maksudnya, probability of defective item. So, P dekat sini kan kita nak cari P. P dekat sini, probability of success di sini will be the probability of defective item. Sebab defective item ni adalah success. Okay, so P adalah number of defective item. So, dia kata since the items are selected independently and we assume that the process produced a 25% defective. Dia dah bagi tahu kat sini 25% defective. So, P adalah 0.25. So, P adalah 0.25. So, here dia punya P adalah 0.25. Power of X. X can be 0, can be 1, can be 2, can be 3. And then 1 minus P ataupun Q is 0.75. How I get this? 1 minus P. Okay. And then 3 minus X. Okay, your possible value will be 0, 1, 2, 3. 0 until N. N is 3. 3 trials. So, kalau you buat secara manually, you akan dapat this table lah. Kita buat. Alright. So, this is the function for binomial distribution. So, actually, daripada sini, daripada this distribution tadi, kita dah boleh carilah. Nak cari probability of number of defective item is 3. Contohnya. So you gantikan X sini dengan 3. So, it will be, tak nampak saya buat kat sini. Let's say nak cari probability of X equal to 3. So, it will be 3C3 multiply 0.25 power of 3, 0.75 power of 3 minus 3 is 0. So, you calculate this, you akan dapat the probability of X equal to 3. Okay, so no need for you to find to create this PDF table. Tapi you akan dapat jawapan yang sama. Okay, let's see kalau you nak cari probability of X less than or equal to 1 contohnya. Number of defective item is not more than 1. Okay, so less than or equal to 1. So which is probability of x equal to 0 plus probability of x equal to 1. So how to get this? First, gantikan x di sini dengan 0 and then gantikan x di sini pula dengan 1 dan total that out. Okay, so you akan dapat the probability. Okay, macam ni tadilah. Okay, ini yang saya tunjuk tadi. Ini dia punya function. So kalau kat sini kita juga boleh tulis x ni adalah number of defective item sebagai distributed with binomial distribution with parameter n-nya 3, p-nya 0.25. So kalau tulis macam ni, you boleh tahu dah p dia 0.25, then you can create this function. Okay, together with the possible value. Pernah ada juga. Okay, kita tengok example kat bawah ni. The probability that a certain kind of component will survive a shock test is 3/4. Find the probability that exactly 2 of the next 4 components tested survive. So, survive dekat sini, dia punya probability is 3/4. So, kat sini kita boleh katakan this distribution for the variable number of survive component adalah binomial distributed. Sebab kat sini ada dua outcome je, sama ada survive or not. Dan dia bagi probability of survive adalah 3/4. So kita boleh first kali cari dulu what is the variable. X-nya adalah number of success tu ataupun number of, kat sini success-nya adalah survive. So X will be number of component will survive the test. So P will be the probability of success, which is the probability of survive the test, which is 3/4. So, kita boleh tulis X sebagai binomial distribution. Kena tahu dia punya N. Macam nak tahu N, kat sini dia bagi tahu find the probability of the exactly 2 of the next 4 component. So, N is 4. So, N is 4 here. P adalah 3/4. So from this, we can create the function of fx, which is 4cx 0.75 ataupun 3/4 power of x 0.25 power of 4 minus x. X can be 0 sehingga 4, which is until n. So we have this function. Bolehlah you nak cari probability of that exactly 2 tested survive. So nak cari probability of x equal to 2. So once you have this function tadi, bolehlah terus cari probability of x equal to 2. Just gantikan this x dengan 2. Last kali you akan dapat this lah. You akan dapat 27/128. Okay, tengok lagi another example. Okay, let's see this. Example 5.2. The probability that a patient recover from a rare blood disease is 0.4. Okay, patient recover from a rare blood disease is 0.4. So dia bagi probability of patient recover. If 15 people are known to have contracted this disease, what is the probability that at least 10 survive, 3 to 8 survive, and exactly 5 survive? So like I said just now, first kali you baca the statement, cari dulu what is the variable of interest kat sini. The success kat sini adalah number of recover patient. Kan? And the probability of success adalah 0.4. So from there, satu lagi kita nak tahu dia punya n, which is 15. So from there, we can create the function, which is 15 cx 0.4 power x 0.6 power of n minus x, and then x adalah from 0 sehingga 15. So once we have this function, bolehlah you nak cari any probability. So kat sini dia nak dapatkan probability that at least 10 survive. So more than or equal to 10 will be survive. Alright. So sama ada you kira 10, 11, 12 sehingga 15 ataupun 1 minus x less than 10 pun boleh. Actually ada satu lagi, kita boleh gunakan binomial table. Sekejap lagi saya tunjuk. Okay. So yang kedua pula, nak cari probability that at least from 3 to 8 survive. So nak cari probability of x from 3 to 8 survive. So you boleh cari probability of 3, 4, 5, 6, 7, 8 that will survive. Last kali exactly 5 survive. So just masukkan dalam this formula. Okay, yang ni yang dia tunjuk kat sini gunakan table sebenarnya. Sekejap lagi saya tunjuk cara nak guna table. Okay, let's see this. A larger chain retailer purchases a certain kind of electronic device from a manufacturer. The manufacturer indicates that the defective rate of the device is 3%. The inspector randomly picks 20 items from a shipment. What is the probability that there will be at least one defective item among these 20? So daripada sini, like I said just now, what is x? X adalah number of defective. Betul tak? Sebab dia bagi dekat U kat sini, probability of defective rate. Probability of defective ataupun defective rate adalah 3%. Number of defective electronic device. And then dia punya P adalah 0.03. Then you can create the function. So it will be, and then from here dia katakan from 20 items. So n is 20. So 20 cx 0.03 power of x 0.97 power of 20 minus x. X can be from 0 until 20. So once you dah ada this function, boleh jawab soalan. What is the probability that there will be at least one defective item among these 20? So nak cari probability of x more than or equal to 1. So sama ada you cari x equal to 1, x equal to 2 sehingga 20, ataupun lagi senang you cari 1 minus probability of x equal to 0. So 1 minus, macam nak cari probability of x equal to 0, just masukkan dalam this function tadi. Okay, 20C0 is 1. Okay, 0.03 power of 0 dan 1 minus 0.03 ataupun 0.97 power of 20 minus 0, you will get this answer. So dia kata pula, suppose that the retailer received 10 shipments in a month and the inspector randomly tests 20 devices per shipment. What is the probability that there will be exactly 3 shipments, each containing at least one defective device among the 20 that are selected and tested from the shipment. Okay, saya macam mana jawab soalan ni? Okay, in this case, each shipment can either contain of at least one defective item or not. Hence, testing of each shipment can be viewed as a Bernoulli trial with P 0.4560. Okay, sebab dia kata, suppose that the retailer received 10 shipment in a month and the inspector randomly tests 20 devices per shipment. What is the probability that there will be exactly 3 shipments, each containing at least one defective item? Okay, ini adalah probability daripada soalan A, at least one defective item daripada 20 tadi. So, dia punya probability adalah 0.4562. So, we will use this P ataupun the probability of success, the new probability of success untuk B. And then sekarang dia punya N adalah 10. Kenapa? Sebab dia kata dia receive 10 shipment. So now our new variable, let's say kat sini dia buat sebagai Y pula. Y adalah number of shipment containing at least. Okay, Y adalah number of shipment containing at least one defective items, and the shipment adalah we have 10 trials. So dia punya kita punya variable yang baru adalah Y, binomial 10, P-nya adalah 0.4562. So we have the new Fy, which is 10Cx, 0.4562 power of x, and then 1 minus 0.4562 power of 10 minus x. X can be from 0 until 10. So, soalan ni nak dapatkan exactly 3. So, masukkan Y kat sini dengan 3, you will get this answer. Okay. Okay, untuk special discrete ni, you kena tahu functionnya. You kena tahu function untuk binomial apa dia. Tadi kan NCX, P power of X, 1 minus P power of N minus X, X from 0 until N. And together with that, you need to memorize the mean dan juga variance of binomial. This is the mean and variance untuk binomial, kena hafal. Mean-nya adalah N darab dengan P, N number of trials, P adalah probability of success. So, NPQ here adalah, Q here adalah number of failure ataupun 1 minus P. So, mean-nya NP, variance-nya NPQ. Kalau nak calculate, kalau nak determine, macam sebelum ni kan, actually nak cari mean untuk discrete macam biasa. Kita boleh gunakan mathematical expectation, which is X, PX, right? So, tadi you ada function fx, you ada possible value of x, you boleh buat table ni, kan? And then you carilah setiap ni, satu ni, boleh dah dapatkan expected of x. Last kali you akan dapat n darab dengan p juga. Okay, you boleh try. Ini dia punya proving. But it is an advantage for you if you can memorize the mean dan juga variance. Lagi cepatlah untuk you nak jawab soalan nanti. Kalau you dah tahu the variable is belong to binomial distribution, disuruh cari mean, so just gunakan this formula untuk cari mean dan variance for that variable. Okay, so kalau variance samalah macam sebelum ni, kalau nak gunakan mathematical expectation, the variance will be expected of x minus dengan mean square, kan? So, if you have this table, you boleh cari. So, you akan dapat nanti NPQ lah, dia punya proving. So, like I said just now, once you have the function, apa yang you kena ingat di sini adalah function fx. You kena tahu dia punya parameter untuk binomial adalah p, and then you kena ingat dia punya mean dan variance. Mean adalah NP dan variance adalah NPQ untuk binomial. Okay. Application, tengok sikit application untuk binomial ni. Biasanya digunakan di mana? Okay, actually beberapa field biasa menggunakan binomial distribution. Contohnya, an industrial engineer is keenly intertested the proportion defective in an industrial process, sama ada defective or non-defective. Often, quality control measure the end sampling scheme for the process are based on the binomial distribution. This distribution applies to any industrial situation where an outcome of a process is dichotomous. Maksudnya ada dua lah dichotomous ni, failure or success. And the result of the process are independent, with the probability of success being constant from trial to trial. Dia punya independent tadilah. Maksudnya first trial, dia punya probability of success sama juga dengan second trial. Okay, the binomial distribution is also used extensively for medical dan juga military application. In both fields, a success or failure result is important. For example, penyakit tu cure or non-cure. Ada dua saja. Dichotomous. Ada dua saja kita punya possibility, success or failure, cure or non-cure. Ataupun hit or miss. Untuk fire guided missile contohnya. So, ini adalah some of the application in the field of engineer, medical dan juga military yang biasa digunakan in application of the binomial distribution. Bila kita ada dua outcome, so kita boleh gunakan binomial distribution when we have n trials. Kalau satu trial saja, ianya dipanggil Bernoulli. Okay, sama juga macam Bernoulli. Bernoulli tadi kan, kita dah ada function dia. You kena tahu juga dia punya mean dan variance. Okay, ini function untuk Bernoulli. So, mean untuk Bernoulli adalah P dan variance untuk Bernoulli adalah PQ. Sebab dia punya n kan satu saja. 0 and 1. N dia satu trial saja. So, satu darab dengan P tadi, NP. Dan variance and PQ yang tadi satu. So, mean dia P, variance-nya PQ. Alright. Okay, let's look at this another one question. Dia ada trick sikit kat sini. Okay, so saya nak tunjuk this example. So, example-nya adalah one specialist medical doctor claims that 40% of those with lung cancer are chain smokers. Okay. If assertion is correct, find the probability that 8 such patients recently admitted to a hospital, fewer than 2 are chain smokers. Nak cari probability that fewer than 2 are chain smokers. So, yang kita ada kat sini 40% cancer are chain smokers. So, kita boleh katakan X kita adalah number of lung cancer patient are chain smokers. And dia punya probability of the lung cancer patient are chain smokers adalah 40%, 0.4. So, from here, we can create the function. So, kat sini dia kata 8 patient, so n is 8. So, 8cx, 0.4x, 0.6, 8 minus x from 0 until 8. So, sekarang nak cari probability of the chain smokers are fewer than 2. Okay, fewer than 2. So, it is probability of x equal to 0, probability of x equal to 1. Sorry, tambah. Okay, plus probability of x equal to 1, 0 and 1. So, how to get this? Just replace x here with 0 and replace x with 1. So, you akan dapat jawapan. Tengok yang B pula. find the probability that 5 such patients recently admitted to hospital, more than 3 are not chain smokers. Tadi kita punya X adalah chain smokers. So X kita kat sini adalah number of lung cancer patient are chain smokers. Their probability is 0.4. This is the function. Sekarang ni dia nak cari probability more than 3 are not chain smokers. So you tak boleh gunakan this function nak cari this probability. Sebab kita punya variable berlainan. Ini chain smokers, yang ni not chain smokers. Alright. So dekat sini dia bagi you probability untuk chain smoker. So sekarang kita ubahlah kita punya variable Y. Sekarang adalah number of patient. Kita punya success sekarang adalah number of patient, lung cancer patient are not chain smokers. Walaupun dia bagi you probability of chain smokers, tapi soalan nak untuk not chain smokers, so you kena tukar. So, dia punya probability of success kat sini adalah probability of patient that are not chain smokers, which is 0.6 ataupun number of failures sebenarnya. Dia bertukar menjadi number of success sebab kita nak cari probability patient are not the chain smokers. And dia punya n sini berubah, dia berkata 5. So, kita punya new function will be 5 CY 0.6 Y 0.75 minus Y. So Y will be from 0 until 5. So barulah you boleh cari probability of Y more than 3. More than 3. So it will be probability of X equal to 4 dan probability of X equal to 5 using this new function that we created. Right? So, boleh nampak kat situ dia boleh berubah daripada success kepada failure, failure kepada success. Depends pada question ataupun depends pada variable. Okay. Nanti dalam your textbook ni actually ada banyak lagi kat bawah tu example. So, you boleh bacalah. Okay, macam ni. Alright.